Hi, my name is Aaron Sampson. Cloud computing has transformed IT operations, offering scalable and cost-effective solutions for businesses. In this course, we'll explore cloud computing benefits, highlight cost savings, scalability, and efficiency, analyze cloud service cost implications, helping you to understand the financial considerations of cloud adoption, provide a deep dive into cloud models, including public, private, hybrid, and community clouds, along with infrastructure as a service, platform as a service, and software as a service models, give insights into cloud storage, virtual machines, and virtual networks, ensuring you can manage and configure cloud environments effectively, explore cloud characteristics such as multi-tenancy, measured services, elasticity, and high availability, and develop expertise in creating virtual machines, configuring virtual networks, and deploying cloud storage solutions. In this video, we'll introduce cloud computing, which in itself is the delivery of computing services such as servers, storage, databases, networking, software and applications, and many other services over the internet. And this enables on-demand access to those resources, but without having to manage any of the infrastructure. Now, I'll talk about that in greater detail in just a moment, but with respect to the cloud in general, all things considered, it's a relatively new approach to computing, but the idea is that any type of resource, such as a server, really can be anywhere, particularly these days where we do have very fast internet speeds. So it ultimately doesn't really matter where the resources are. So any organization can, of course, have all of these components on their own. But the cloud providers, most notably Microsoft, Amazon Web Services, and Google, have extraordinary resources at their disposal compared to most organizations. So they can create an infrastructure that most organizations simply can't afford or just don't have the means to support those resources, even if they could afford them. So we basically just take advantage of the fact that these providers can create all of this infrastructure, and we just use them whenever we need them for whatever it is that we want to build. So by taking this approach, we no longer need to implement any of that infrastructure in our own on-premises environment. As for why businesses are moving to the cloud, it can be significantly more cost efficient. Now, this does depend on the nature of your environment and what it is that you need to do, because some environments may have already made significant investments into their own infrastructure, so it wouldn't make much sense for them to not take advantage of those investments. Plus, many cloud services can still be quite expensive, so it might come down to how long you intend to use those services for, and if you weighed everything out over the long term, it might actually still be cheaper to implement the solution locally. So it's not always more efficient, but generally it is, and again, we'll talk about this in greater detail in just a moment. It is certainly more accessible and highly scalable. Accessible because it's basically accessed over the internet, so as long as you have internet connectivity, you have access to the resources in the cloud. As for highly scalable, again, this comes back to the fact that the cloud providers themselves have virtually unlimited resources from the perspective of any given customer. So you can just keep adding more servers, adding more storage, more memory and processing power. Really, whatever it is you're using, you can just keep adding. And it also promotes enhanced collaboration and remote work capabilities because, again, everyone can access the same resources and from anywhere at any time. So coming back to the cost efficiency and resource optimization, the lowered infrastructure costs is due to the fact that cloud services can entirely eliminate the need for expensive on-premises hardware. So again, this depends on the nature of your environment. If, for example, you already have an office space and you have many users that all have their own devices, then that's going to remain in place. But as for the network servers, the applications that you need, and really any other services, all of that can be implemented in the cloud. So for whatever it is that you're going to implement, you simply do not need to purchase the infrastructure locally. You can just use what the cloud provider already has. And it's also, in most cases, based on a pay-as-you-go pricing model, which reduces capital expenditures because, again, we do not need to purchase the infrastructure, and you only pay for what you actually use in the cloud. So again, it can really help to bring down your costs. As for optimized resource allocation, the services that you implement can, in many cases, scale automatically based on the demands being placed on the workload. So if, for example, you have a website and the traffic on that site starts to increase, you can configure it so that additional nodes will be implemented into a cluster, or that additional memory and processing will be allocated to the virtual machines. And it's not just about adding those resources. When the workload decreases, then those resources will be deallocated so that you don't end up paying more than you need to. And this also helps to reduce wasted computing power and energy consumption. So then, with respect to comparing the cloud to traditional IT models, again, in all cloud situations, it can reduce upfront investments compared to purchasing dedicated servers. So again, if you are about to release a new product or a new service and you are going to do it in-house, you might need to buy new servers and new equipment to support it. But in the cloud, you don't have to buy any of that. Everything is already there, and you just make use of the components and services that you need. And there are various different price models that offer flexibility in budgeting. Now, among the more common is the aforementioned pay-as-you-go, wherein you literally just pay for what you use, but it can depend on how much you use and how often a particular service is needed. So there are some other options that are based around subscriptions and or discounts for bulk use. So it will depend on the provider, but there are a few different options. So hopefully you can find the one that best suits your organization. As for scalability and performance enhancements, again, the idea behind on-demand scalability is that you don't have to do anything to respond to increases in the demands on the workload. Another example might be a database server. If the workload increases, then new nodes can be allocated automatically to a cluster. More storage can be allocated, more network bandwidth, again, more processing and memory. So all of this can happen automatically so that you never have to manually go and reconfigure your systems. There are also various performance options that you can typically choose from. For example, for any particular type of application, you can choose what kind of virtual machine is required to host it. Maybe it needs more and faster processing than normal. Maybe it needs more memory. Maybe it needs faster storage or more bandwidth. So again, you can choose these options so that you can fine-tune the needs of the application or service. And again, since the cloud is simply on the internet, it has a global reach. As long as you have connectivity to the internet, then you can access your cloud environment for building and administering. And of course, your customers can reach your services as well. Security and compliance considerations are also provided by the cloud provider. So they have many built-in security features. Again, in most cases, far more robust than what many organizations can implement on their own. So you can decide for yourself which security features you need. And the cloud providers also need to be compliant with many different regulations and standards so that the solutions we build will themselves also be compliant with various standards. Now, those standards depend on the type of business you're in and where you are, but virtually every major cloud provider offers services that are already compliant with a number of different regulations. So again, you need to concern yourself with ensuring that this particular piece of hardware or this particular service or this method of storage is compliant, because the infrastructure itself and the services they offer are already compliant. They also provide the means to implement disaster recovery strategies and business continuity, and once again, in most cases, to a degree that many organizations simply could not achieve on their own because they have so much in terms of resources. So we can build redundancy, we can ensure failover, and we can help to ensure that our services remain running even in the event of a disaster. And finally, with respect to collaboration and remote work, again, it provides for seamless collaboration because virtually everyone within your organization has the ability to access the same resources. Now, of course, you can control that. You're able to determine who has access to what, but it facilitates the ability for anyone to access anything. So you can set up your various teams and you can ensure that whoever needs access has access. And again, because it is on the internet, remote access is inherently available. Now, you can still configure things like VPNs for some of the virtual networks that you create, but again, you do not need to purchase any equipment whatsoever. You simply configure it as a service in the cloud, but because it's on the internet, it's already inherently available in any situation. So again, as long as your workers have internet access, then they have the ability to access your cloud services. So there are a tremendous number of benefits to using cloud services. So if your organization is in a situation where you're considering a migration to the cloud, certainly bear all of these factors in mind. In this presentation, we'll provide an overview of some cloud cost considerations. Now, ultimately, understanding the pricing model can help an organization to budget out their expenses and avoid any unexpected expenses. Now, the more effectively you plan, the less likely it is that something unexpected would happen, and that's applicable to anything. But if you consider something like your on-premises hardware, something might entirely unexpectedly break down. So in some cases, there's not much you can do about that other than react. But in the cloud, that is not an issue at all in terms of physical infrastructure, that is. If a piece of hardware fails, for example, it is entirely up to the cloud provider to replace that hardware, and it costs us nothing. So this can really help to enable cost-effective resource allocation. But we still need to understand what the costs are so that we can still try to be as cost-effective as possible. This helps to support decision-making for scaling cloud services if and or when we decide we want to migrate more of our services to the cloud, or maybe go the opposite way and bring certain services back into the on-premises environment. So then in terms of factors affecting cloud pricing, they are primarily based on what we use, which includes compute power, storage, and data transfer costs, among others. And the geographic data center locations and any compliance requirements that might be applicable to your organization can also be a factor. And certainly the choice of pricing model. Most providers will give you a few different options in terms of pricing, such as pay-as-you-go and what's known as reserved instances. But in terms of those choices, some common models do include the pay-as-you-go option. Now, this is essentially on demand, meaning that as you need it, you can certainly use it, but the more you use, the more you pay. So this is exactly like our home utilities: power, heat, hot water. The more we use, the more it costs us. But at the same time, if you don't use it, it doesn't cost you anything. So you do not pay for what you do not use. Now, reserved instances are based on the fact that the cloud is a shared environment. We are all using the same physical infrastructure of the provider. So just as a very simple example, if I host a website and you host a website, those two sites might ultimately end up on the same server. So the resources of that server are being shared amongst multiple tenants. But what you can do is to request a reserved instance, which means that you'll get dedicated infrastructure for whatever that instance is. And perhaps more to the point, you won't be sharing it with anyone else. So that typically gets you better performance, but of course, it's going to cost more as well. On the flip side of that is what's known as spot and or preemptible VM instances. So these are virtual machines that are just like any other virtual machine, but they are essentially built out of leftover resources, for lack of a better word. So if there are situations where this collection of physical servers can support extra virtual machines, then the providers will spin those systems up using those leftovers, so to speak. But they're referred to as preemptible because at any point in time, if the resource utilization of that server gets too high, these are the ones that are sacrificed, if you will, to ensure that the performance can remain for the other customers. So in short, they cost a lot less, in some cases up to 85% less, but you would never want to run a mission critical workload on a spot or a preemptible instance because it literally could be lost at any time. But when you're just doing temporary operations, they can be a good option. And then subscription-based pricing typically tends to be more along the lines of a flat rate, where you pay a set amount each month, then you get X amount in services. You might be able to exceed that at any point in time, but you would pay extra if you do. As for some hidden costs in cloud services, for starters, this is not to suggest that a cloud provider is going to attempt to hide costs on you, but you might need to be mindful of things like data transfer fees. So you might be paying a subscription, for example, but there might be additional fees if you exceed a certain amount in terms of data transfer. Underutilized resources could also end up costing you because it literally means that you're paying for something that is not being used, but this is where features such as auto-scaling can help. And storage costs beyond the provision capacity can also cause extra charges. So again, this might be a situation where you have allocated a certain amount for a particular service, then all of a sudden it's necessary to allocate more, which you might not have anticipated. So again, that additional storage is going to result in additional costs. So some strategies to help optimize your costs include what's known as right-sizing your resources. Now, in many cloud environments, they will actually provide estimators wherein you'll be prompted to answer certain questions about configuring a new service, and it will help to guide you and suggest that you use this type of virtual machine or this load balancer or whatever it is, but it quite literally helps you to pick the best pricing option. They typically also offer cost management tools whereby you can maybe configure thresholds so that you'll be informed once a certain value is reached, and you can maybe reconfigure things a little bit. And you also get bills, basically, reports at the end of each month that will summarize what you used and where. So again, you can do things like leveraging the aforementioned reserved and or spot instances. Now again, reserved means that you've got dedicated hardware. They're going to cost more, but they In this video, we'll provide an overview of cloud service models, and these define how cloud computing resources are deployed and accessed, and each particular model has an impact on the cost, security, scalability, and the means by which each model is managed. Now, why are there even different cloud models to begin with? Well, not every organization is the same. We all have unique needs for infrastructure, security, and compliance, so each model offers specific benefits and trade-offs depending on those needs. Now, I do want to quickly mention that there are 5 options, and we'll see them all here, but really there are only 2. The last 3 that we'll take a look at are just various combinations of the primary 2. So the first model is a public cloud. And for all intents and purposes, this is what almost everyone thinks about whenever someone talks about the cloud. So in a public cloud, the resources are owned and operated by third-party providers such as Microsoft, Amazon, and Google. They own everything. We simply use all of their infrastructure to build the services that we need. And those services are simply delivered over the internet, but built on a shared infrastructure because all of us use the same infrastructure of the provider. This is a very cost-effective model, in most cases using a pay-as-you-go model, but in the previous video, we did talk about some other options with respect to pricing, but that's certainly the most common. It is highly scalable with easy access to computing resources. Again, the providers themselves have virtually unlimited resources, so we can scale as much as we need. And there is no infrastructure maintenance required by us as users. Everything to do with infrastructure is entirely the responsibility of the provider. So again, of course, we pay for our services, but when it comes to physical infrastructure, we don't need to do anything. Now, the other option is the private cloud. And in this case, this is a dedicated cloud infrastructure for a single organization. Now, in terms of where it actually resides, it can be hosted in the on-premises environment of the organization itself or by a third-party provider. But the idea is that for whatever services you create, all of them are consumed only by the internal organization. No one on the public internet has access to the private cloud. So this offers greater security, control, and compliance in almost all cases because it's entirely up to you how you implement your services. It's also very customizable in terms of tailoring all of the infrastructure to your particular business needs, but it can have a much higher cost compared to the public cloud. Now, it's not guaranteed that that's going to be the case. Again, public cloud services can be expensive. It depends on what you're using. But in a public cloud, you never have to purchase and or maintain any infrastructure at all. Whereas with a private cloud, you absolutely still need that internal infrastructure. So that doesn't really sound any different than just any other on-premises environment. So how is it a cloud? Well, it's typically something that's implemented when you have many different locations. So let's just say that you have a primary data center. Let's just call it headquarters. Then you have multiple branch offices, maybe scattered throughout the region or around the country or even around the world. But all of the infrastructure, or at least most of it, would reside within that headquarters or that central data center. So all of the services are accessed from there. All of the branch locations then use that infrastructure just like you would in a public cloud. In other words, they would have very little in terms of infrastructure in their local environments. And in those branch locations, all services are simply accessed over the internet, but they still come from that headquarters location. So if I'm in one of those branch offices and I need to configure a virtual machine, I still do all of that through probably some kind of customized web interface, but the virtual machine itself gets implemented back in the primary data center as opposed to on the public internet. So again, the costs tend to be higher because of all of that infrastructure, but in the long term, and again, depending on what you need, it's not as though it's always going to be more expensive. It really just comes down to the fact that you need that infrastructure. So then these are the other options that I mentioned, and we'll begin with a hybrid cloud, which is quite simply a mix of both public and private. So again, it's not that hybrid is anything really distinct on its own. We still see the public cloud and the private cloud. We're just using both. So this allows for data and applications to move between environments if necessary. It provides flexibility in terms of both cost efficiency and security because it enables businesses to maintain more sensitive data in the private cloud while leveraging the public cloud for anything that requires very high scalability and or performance. And it supports workload balancing and disaster recovery. In short, some of your operations occur locally within the private cloud. Some of them are in the public cloud. So since you have both, you certainly gain more flexibility overall, but it can also be a little more complex to set up and manage. Now, the last two are what's known as multi-cloud and community cloud. So beginning with multi-cloud, this is still a public cloud model, but it means that you're using multiple cloud service providers to avoid dependency on a single vendor. This can help to enhance redundancy, performance, and possibly adherence to compliance. So as an example, you might use Amazon Web Services for all of your compute services and Google Cloud for your analytics. Now, what you put where is entirely up to you, but a multi-cloud environment simply means you are using more than one public cloud provider. And finally, the community cloud is a shared infrastructure that is typically tailored for specific industries or groups that tend to have many things in common in terms of what they need to do. This can offer the same benefits of a private cloud, but with cost sharing amongst all participants. So you do still see localized infrastructure somewhere, but all participants can share in the costs. So it's still very much like the private cloud, where I mentioned the data center as headquarters, then the branch or regional offices. But in this case, each location would be a different organization, as opposed to everything being all the same organization. So this tends to be more common in research institutions, government agencies, and healthcare. Again, industries or institutions that tend to have common needs. So as mentioned, when it comes to hybrid, multi-cloud, and community cloud, at the core, you still see public and private clouds. It's just some variation with respect to how they're being implemented. And when it comes to a community cloud, of course, you would also have to factor in all of the coordination that's necessary amongst all members to even implement it in the first place. But they are still all options. So once again, it just depends on your particular needs. But whatever your needs are, there is most likely a cloud service model that can provide for them. In this presentation, we'll provide an overview of Infrastructure as a Service, or IaaS, which is a cloud computing model that provides virtualized computing resources over the internet, which in itself eliminates the need for physical data centers and reduces the infrastructure costs for any given organization. Now, that in itself is true of really any type of cloud service, but the key aspect of infrastructure as a service is that you're focusing on actual infrastructural elements, but this still does not mean that you need to implement any infrastructure yourself in your own environment. Everything still resides within the cloud, and even though we're using these low-level resources, so to speak, and we'll see more specific examples of that in just a moment, it doesn't mean that you need to do anything in terms of looking after those resources. You're still just using them to build the solutions that you want. So some of the key characteristics of IaaS include very scalable computing resources, such as virtual machines, storage, and networking configurations. It offers on-demand provisioning and still offers a pay-as-you-go pricing model, so you still only pay for what you use. But all of the hardware that is implemented is still managed and maintained by the cloud providers. So again, despite the term infrastructure in IaaS, it does not mean that we have to look after any infrastructure at a physical level. It's still virtualized, but one of the best examples is listed right there, a virtual machine. That is still a server like any other. We just do not have to look after the physical server that hosts the virtual machine. We only need to concern ourselves with the virtual machine itself. So as for some of the core components of IaaS, they include what is generally referred to as compute resources. Now, once again, the best example of that is a virtual machine, but there are some variations in that regard. For example, containers are also part of compute resources, and those are lightweight, self-contained software packages that include everything needed to run an application, making them entirely independent of any particular host computer and even the operating system. In other words, you do not have to install a container. You can literally just move it from one system to another, and it will run just the same on either one. Another example is what's known as serverless computing. Now, this still uses virtual machines, but it goes a step further, if you will. If you imagine a standard virtual machine, for lack of a better word, in the cloud, I might still have to look after that virtual machine, but what I don't have to look after is the physical server that runs it. So with serverless computing, this goes a step further in that there is still a virtual machine, but I don't even need to look after that. So developers typically build applications using serverless computing. There is still a virtual machine that provides the processing, but it's all in the background, so to speak. So the provider handles both the physical server hosting the virtual machine, and they handle the virtual machine. We then just take advantage of that computing power. Storage is another core component of infrastructure as a service, as is networking and security and identity management. So again, the core services, if you will. So then in terms of the benefits, it offers a very cost-efficient model because we do not have to purchase any of the physical infrastructure. We just take advantage of it. It's very scalable and flexible because we can just keep adding more and more of whatever it is that we need. And it provides for better business continuity because, again, it's not up to us to concern ourselves with the physical hardware. So if a physical server at the cloud provider fails, then it's up to them to ensure that our virtual machine is moved to another system that is still running. So that greatly helps to maintain business continuity. In terms of some of the use cases, it's commonly used for website hosting, big data analytics, software development and testing, and disaster recovery and backup. But the key aspect, if you will, is simply the fact that we're focusing on the infrastructural elements. So for something like website hosting, that's certainly a common example, but the approach in this case would be that I'm going to go into the cloud environment and I'm going to create a virtual machine. Then I'm going to host a website on that virtual machine. This gives me greater control over the server itself, what kind of operating system I want, what kind of configuration I want. Then I can host my website on that virtual machine. And again, I do not need to concern myself with the physical infrastructure at all. So I can create whatever type of virtual machine I want, with whatever specifications I want, with whatever operating system I want. So again, you get a lot of control when using IaaS in this case. Some considerations for choosing the right IaaS provider include the performance and reliability of their physical hardware, the security and compliance that they can offer, and the various cost and pricing models that are available. Now, I do want to point out here that the IaaS model is not something that you specifically have to choose, and all of the major cloud providers of Amazon Web Services, Microsoft Azure, and Google Cloud offer IaaS. So it's not as though you go into the interface and you choose a menu option that says, I want IaaS services. If you just log into their interface and let's just say create a single virtual machine, then you are already using IaaS. It's just what they would offer in terms of the virtual machine. What operating systems do they have? What other software components might they provide? What's the cost? What other security features are available? So they're all still considerations because each one certainly does vary a little bit. But again, every major cloud provider offers infrastructure as a service. So then finally, when it comes to the IaaS offerings of each provider, they include Elastic Compute Cloud, or EC2 in Amazon Web Services, virtual machines in Microsoft Azure, and the Google Cloud Compute Engine. Now, again, each one will have variations with respect to the compute resources they offer, such as serverless computing and containers and virtual machines, but these are just the classifications that they tend to use for purposes such as billing. But in terms of navigation, when you do go into the primary portals, you would certainly see a section for virtual machines in all three. But there might be a navigation menu over on the left-hand side or something along those lines, and you might see options such as Elastic Compute Cloud, and once you click on that, then you would see the more specific services of virtual machines, serverless computing, or containers, and the same thing goes for Google Cloud. You might see a menu option that says Cloud Compute Engine, then you'd see the more specific services, but those are just navigational tools. Again, you don't have to sign up in terms of a subscription for IaaS in general. It's just that this focuses on these lower level resources so that you can then build your solutions on those resources, and what you build is entirely up to you. It's just that generally IaaS is chosen because you do want to start from scratch, so to speak. You want that control over the infrastructural elements, then you build up from that point. So again, the idea is that IaaS starts at the infrastructure level, but again, bear in mind, it's not the physical infrastructure. That in and of itself is always maintained by the provider, but it's certainly up to us to implement and maintain whatever it is that we build on that infrastructure. In this video, we'll provide an overview of Software as a Service, or SaaS, which is a cloud-based software delivery model, and all of that software is accessed via the internet, which eliminates the need for any local installations and/or maintenance. Now, we'll compare SaaS to some of the other models, such as Infrastructure as a Service and Platform as a Service, in just a few moments. But you can generally think of Software as a Service as the opposite end of the scale to Infrastructure as a Service, because there is no infrastructure required whatsoever other than the client device that you're using. But you typically access the application through a browser, which means you don't have to install anything other than a browser, and the software itself is managed entirely by the cloud provider. So in terms of some of the key characteristics, you still have to subscribe to the software. So they typically have a few different pricing options, perhaps monthly or annual plans. Now that will be dependent on the provider and of course, whichever option you feel better suits your needs. But again, since the applications are maintained entirely by the provider, this means that it is automatically updating and all security patches are applied. But again, you don't need to do any of that. Everything is managed by the provider. So you always get the most up-to-date version. And it provides multi-tenancy support, allowing multiple users to share the resources of that application. So no matter what it is, any or all of your users can access it. Now it's certainly up to you to determine who should be able to access it, but anyone is able to, provided they have a user account. As for some benefits, it's a very cost-effective model because, again, you do not need any infrastructure, nor do you need to purchase any software. It does not have to be installed. There are no licensing considerations. So again, you just pay on a monthly or annual basis. It is highly scalable. Really, you can just keep adding users. And again, it's up to the provider to ensure that the infrastructure in the cloud is there to support the performance requirements of the application. And it's entirely accessible. As long as you have internet access, then you have access to the software. Some common SaaS applications include business productivity tools such as Microsoft 365, Google Workspace, or Dropbox, customer relationship management or CRM software such as Salesforce, HubSpot, or Zoho CRM, enterprise resource or ERP planning applications including SAP, Oracle NetSuite, and Workday, and collaboration and communication software such as Slack, Zoom, and Microsoft Teams. But again, the idea is that all of them are simply applications that run in the cloud, and we access their services entirely over the internet. So as mentioned, if we compare SaaS to some other cloud models, again, no infrastructure is required to support it. Whereas if you use Platform as a Service, which by the way we'll talk about in the next video, this typically involves some kind of a development platform such as Google App Engine or Amazon Web Services Lambda, but there is some infrastructure in PaaS, and it's not about ready-to-use software, it's about building software. So typically you find a Platform as a Service implementation in environments that are developing applications themselves. Then IaaS is, again, kind of the opposite of Software as a Service because we aren't really focusing on the software, rather the infrastructure, virtual machines, storage services. Some examples include Amazon Web Services EC2 and Azure Virtual Machines. Now, with infrastructure as a service, you can certainly still implement either Platform as a Service or Software as a Service as sort of an ultimate end goal, if you will, but you would still have to manage the infrastructure. So, for example, I might create a few virtual machines, and they might host development suites or web services so that my developers can build on those systems. Or they might host an application that your employees would use. So again, you can create PaaS and SaaS implementations from IaaS, but once again, the key is that you would have to look after that infrastructure, whereas with SaaS, there's no infrastructure whatsoever. Now, there are also some security and compliance considerations, but SaaS providers will implement features such as encryption, and they'll provide access control so that we can create user accounts and permissions, and they'll also implement measures to ensure that the software that we use remains in compliance with any regulations that might oversee your operations. Users must ensure proper data governance and backup strategies. So again, it's not as though the cloud provider is responsible for everything. They provide the application, but we have to use it properly. We need to make sure that we manage the data through that application on our own, and we need to ensure that everything is backed up so that if it's lost, we can recover. But coming back to some of the compliance considerations, the providers themselves do adhere to standards such as GDPR, which is the General Data Protection Regulation, or HIPAA, the Health Insurance Portability and Accountability Act, so that when we configure the software and make it available to our users, it is also in compliance with whatever regulations we must observe. So again, the idea is that the provider will ensure that all of the tools are in place, but we need to use those tools appropriately. So finally, some best practices include configuring multi-factor authentication for more secure logins, and just regularly reviewing user permissions and access logs to ensure that only the appropriate people are gaining access to the application. And once again, you can, of course, control access to the application by simply creating the appropriate user identities. But once again, that all comes down to how we configure the application. But the idea behind Software as a Service is that the provider ensures that the software is available and that it's maintained and managed and kept up to date. Then it's up to us to ensure that we use the software appropriately. Have to use it properly. We need to make sure that we manage the data In this video, we'll provide an overview of Platform as a Service, or PaaS, which is a cloud computing model that provides both hardware and software tools for application development, which in itself eliminates the need for users to manage the infrastructure required to create that environment, such as servers, storage, and networking. Now, to help clarify, for starters, let's go back and think about some of the other models, such as infrastructure as a service and software as a service. If you very generally think about infrastructure as a service as focusing entirely on the infrastructure, and software as a service having no infrastructure, platform as a service is somewhere in between. Now, I will tell you that PaaS is primarily used in an application development environment, although it doesn't really have to be. But the idea is that if you are a developer, then if you are going to create something like a web-based application, then of course there needs to be some infrastructure somewhere. So if you were in your own on-premises environment, you would very likely create a virtual machine and start building whatever it is you need to build, including the environment used to build the application, so the development environment itself. So you need virtual machines for that. You need virtual machines to host the application once it's finished, and all of that infrastructure needs to be managed by someone. So it still exists, of course. Again, you have to build it on something. But where something like software as a service is a ready-made application with no infrastructure to manage, platform as a service says, I need some infrastructure, but I don't want to manage it. So the developer can basically say that I need a particular configuration of a virtual machine, but that configuration can all be done through the development environment. They can just define the properties through software. Then the cloud provider is then responsible for managing it. So there is still a certain degree of infrastructure, but whereas with IaaS, I would have to completely build that virtual machine on my own and then manage it. In PaaS, I simply say, I need this, and it gets created. Then someone else looks after it on the day-to-day, so to speak. So this, again, is typically used in an environment where we have development happening. It provides the development frameworks, database management, and business analytics tools for our developers to use. And it all helps to support very rapid application development and deployment because, again, the developer need only submit the specifications of the infrastructure required. It is then created immediately and behind the scenes, so to speak. And the development environment itself, such as Microsoft Visual Studio, is available as a service anyway. So you can literally create your development environment within minutes, and you're ready to start building applications. So all of this greatly helps to reduce the complexity of infrastructure management because, again, there really is no management. You only define the infrastructure you need, then the cloud provider handles the management itself. In terms of some of the benefits, this allows for much faster development and deployment so you can get your solutions to market. It's very cost effective because, as always, you only pay for what you use and there are no upfront costs whatsoever. And it helps to increase collaboration because all of your developers can work together, and it also provides source and version control applications so that everyone can work together on the same project at the same time. Common use cases include application development, as mentioned earlier, but it might also just be used for database management or perhaps for AI and machine learning development. But typically, something is being built and developed when using the PaaS model. So then if we compare it to the other cloud models, again, compared to infrastructure as a service, there is still the infrastructure necessary. Okay, so again, we still need web servers and database servers and storage, but developers only need to define what is required within the development studio, then the infrastructure is built automatically. Whereas if we compare it to software as a service, the software is already built. We are simply using an application that is already there. PaaS is much more concerned with building those applications. So again, the idea is to enable much more rapid software development, whereas infrastructure as a service is meant to focus on computing infrastructure, creating virtual machines and networking configurations. And software as a service is for delivering ready-to-use applications. Nothing is being built. We're just using the software that is already there. And again, just to recap what I mentioned earlier, if you consider IaaS to be entirely focused on the infrastructure and SaaS to have no infrastructure, then PaaS is somewhere in between. Finally, as for some security and compliance considerations, there still has to be a certain degree of a shared responsibility here. In other words, the provider themselves must ensure that they offer the services that we need to secure our environment, but it's up to us to implement it correctly. The same thing goes for compliance standards. The services and the infrastructure that is offered by the provider must be compliant in order for us to build a solution that itself is compliant. So again, there is always that shared responsibility. The users must ensure that they are taking advantage of what is made available by the provider to ensure that their solutions are secure and compliant. The responsibility of the provider does not include ensuring that we as users are configuring and using the services appropriately. So in other words, if as a developer, I forget to implement a feature that causes a security vulnerability, that's not the responsibility of the provider. So it's always something to bear in mind. Just ensure that the provider that you've chosen can offer secure and compliant services, but then also ensure that your developers are taking advantage of those services to ensure that their solutions meet the requirements of your organization. In this video, we'll provide an overview of shared resources along with file synchronization. So beginning with shared resources, these are the IT assets of any organization, such as servers, storage, or software. And as is indicated by the term shared resources, this simply means that those resources can be used collectively by multiple users or teams. Now, as for the physical location of any given resource, this really doesn't matter. It could be in your on-premises environment, it could be in the cloud, or maybe you have a hybrid environment where you're using both. So again, it really doesn't matter where the resource is. You don't need to be in a cloud situation just to have shared resources. But in terms of some of their advantages and drawbacks, on the plus side, they do offer operational advantages such as centralized management and better cost efficiency because you're only maintaining a single set of resources. But on the downside, they can cause resource contention because multiple people are now trying to get at the same resource. So that can cause contention. And there can also be security overlap issues because you might have differing permissions for different users, and considerations such as user-based permissions plus group-based permissions, along with things like inheritance, can make it difficult to manage all of the security settings for any given shared resource.